In this video, I will showcase how to run the image analysis component of CamoEvo, including the introduction of custom analyses. To do this, I'm going to load up an existing population. During my first tutorial, I evolved tear-shaped targets against a leaf litter background. I've now extended the number of generations from 5 to 10, with this being the final generation. But how can we compare them against the background? CamoEvo offers the option to regenerate any of the stimuli created. As you will note, that nowhere in the populations folder are any of the stimuli created before. Instead, all of the locations of the targets are stored in the rank files as target X, target Y, target flip, target angle, and then the name of the background image. So we're just going to load up the individuals from the last generation. And you can see them here. So this table here is ImageJ's list of regions of interest. So the first is the region of interest of the target, and then the second is the local background, which is a circle of a radius of 2 times the size of the target. And then this is repeated for each slide. If there are instances where there are 2 targets per slide, such as in the grasshopper population made in the advanced tutorial, such as those made in the custom population in the last tutorial, you will instead have both targets on the same slide, as there were 2 per slide in this instance. Each with their own local background. So what about measuring? So you can either use ImageJ's default measurements tools in order to measure the targets, or you can use some of the custom scripts generated for CamoEvo. So one option is to simply load up the game in CamoEvo, load the game. I'm going to select the tear leaf population, and then select Run Camo Analyses. What this will do is it will start to make a data measures.txt file, and it will measure the LAB values for both the mean and standard deviation for the targets, the global background and the local background, and then also measure the Gabarat values for the targets in the LAB space. What this is actually doing is it's running the image analysis scripts shown here. So you have the batch measure population script. What this will do is it will loop for a population. It will create those ROIs and label them, and then it will pass them to a measurement script. These are the 3 measurement scripts shown here. So what CamoEvo is doing if you run the image analysis is it's automatically running the stimuli LAB, mean, dev, and Gabarat measurement. You also have a measurement for the XYZ. So this is using sRGB to human XYZ conversion from the Mica toolbox. And we also have a measurement of the RNL color difference. So this measures the proportion of the colors of the target which match the colors of the local and global background. So we're just going to let this run. And now we're finally finished. As you can see, it generates the analysis plot that we've seen a few times before. But what we're going to do is we're actually going to look under the hood. If you go into the populations folder, tear leaf, you should now see data combined tear leaf and data genes rank tear leaf. Genes rank, essentially what this does is it takes all of the gene.txt files and all the rank.txt rank.txt file, and it combines them together. So what you have is the generation and the ID. Then you have all of the recordings of the locations and of the rankings. And then after you have all of the target locations, the genes are inserted. So there's not two copies of the gene label. Instead, there's just the one on the left-hand side. All of the measures have been finished. And as you can see, this is an unlabeled .txt file. And then it combines them together in the datacombine.leaf. Now I would like to run a different analysis. So what I'm going to do is rename this. I'm going to delete the data measures.tir. If you don't delete the data measures.tir, it will think that it has already been completed, and it won't bother reanalyzing. The reason for this feature is if you run an analysis and decide you want to play for additional generations, it's useful to not have it rerun all of the existing data, as otherwise you're just wasting time. I'm going to exit the menu. I'm going to go to Plugins, two CamoRec, Image Analysis, Batch Measure Population, Tier Leaf. I'm going to select Measure X, Y, Z. I'm going to let that run. As you can see, it's made a new measures file. It's now X, Y, Z values. And we can then add these to this document later. If you want to make your own image analysis, what you'll need to do is create a custom analysis script. So what I'm going to do is I'm just going to go into the image analysis, measure stimuli LAB. I'm going to pull it up in Notepad. And there's a few things that are worthy of note. So what I typically do is first I set up the measurements. These are the list of arrays of measures that you're going to have. And then in this instance, it's selecting the background image, which is titled background. And it's converting it into an LAB stack using ImageJ's default LAB conversion. I'm then creating the ROIs. So these are pulled from mask. If you only need the target ROI, then don't bother using the local mask, just close the local mask. And then it runs the LAB measurements. So what you'll wish to do is if you want to have your own custom measures, you want to set up an array which you can store all of the titles, and so that it can append the titles if the directory for measures doesn't currently exist. And then you can introduce all of the measures. You want to introduce them in the same order that you have your titles, and then you can append the array of all of your measures at the end. So what I do is I essentially concat all of the measures together into an array that is in the same order as the titles array. So say I wanted to instead measure the RGB color, I would run RGB stack. I'd relabel all of the instances where it says L, A, or B to R, G, and B. These would not really need to change, as it's essentially just taking the measurement. I would renable these LAB just to RGB just to make it clearer for myself in the future. And the Gabra also wouldn't need to change because it's measuring slices. So that is essentially how you can modify your own image analysis using the existing batch image maker. Due to the nature of how ImageJ handles batch mode, it's not able to pass the ROI onto the measurement, and that's why it instead creates a mask in which it passes on the ROI instead. As we can see, it's now coming along nicely with generating all these measurements. And that concludes this tutorial.